Hello everyone. Today I want to explain what is a homogeneous differential equation and how we can recognize homogeneous differential equation. And after that we will solve an example. Let's start. A differential equation is the form dy over dx equal to f1 over f2. That's a standard form. We name it as equation 1. Let's call it a homogeneous differential equation. It's so important. If f1 and f2 has the same degree in x and y. We will explain what is the meaning of this text. Okay, f1 equal to x to the power r phi 1 dy over dx, and f2 as a function of xy equal to x to power r phi 2 dy over dx. If we substitute these two equations in equation 1, we get dy over dx phi 1 dy over dx, which is the f1, over f2, which is phi 2 dy over dx, equal f y over x. Then dy over dx equal to capital F y over x. We name this equation as equation 2. Putting y over x equal to v, then y equal to vx. If we differentiate this equation, we get dy over dx v plus x dv dx. We use it chain rule here and also product rule. Substitute 3 and 4 in equation 2 becomes v plus x dv dx, that is dy dx. We found that dy dx equal to v plus x dv dx, and f y over x becomes fv, since v equal to y over x. Then x dv dx equal to fv minus v. We just take it v from left hand side to the right hand side. Separating the variables, we get dv over fv minus v dy over dx. Integrating both sides, we get the solution in terms v and x. Replacing v by y over x, we get the required solution. How we recognize the differential equation is homogeneous or not? Let's practice together. We have dy over dx. Before we mentioned it that the degree of x and y must be the same. Here we have 1 power of x, here 1 power, it will be 2 power of x. And here we have 1 power of y, here 1 power of y, it's 2. So the powers of x is the same. So we can say this differential equation is homogeneous. Let's solve another example. X dy over dx plus y squared over x equal to y. Let's simplify this equation. By divide both sides by x, it becomes dy over dx y squared over x squared equal to y over x. We know here we have 2 power of y, here 1, it will be 3 power of y. But here we have 2 power of x, here 1, it's 3 power of x, which equals the powers of y. So this differential equation is homogeneous. This one, dy over dx plus y squared over x squared equal to y. We see that we have 2 power of y here, here 1, it will be 3 power of y, but we have only 2 power of x. So we can decide that this differential equation is non-homogeneous. Let's solve an example. Solve x tan y over x minus y second square y over x dx plus x second square y over x dy. Solution. Divide the given equation by dx, it becomes x tan y over x minus y second square y over x plus x second square y over x dy dx. This time, I want to take this term to the right hand side. It becomes x second square y over x dy dx equal to positive y second square y over x minus x tan y over x. This time I want to divide both sides by x second square y over x. We get dy over dx equal to y second square y over x minus x tan y over x over x second square y over x. We have this denominator. It's a common denominator for the numerator, which is 2 terms. So this denominator becomes the denominator of this term and this. So it becomes dy over dx y second square y over x over x second square y over x minus x tan y over x over x second square y over x. This term cancel each other. And this x cancel each other. It becomes dy over dx y over x minus tan y over x second square y over x. putting y over x equal to v and dy over dx equal to v plus x dv dx. Now just replace this two term, this y over x and dy over dx in equation 1 we get, instead of dy over dx we put v plus x dv dx and y over x equal to v minus tan y over x becomes tan v over secant square of v. This two v cancel each other. It becomes x dv dx equal to minus tan v secant square v. Both sides times dx over x, it becomes dv minus tan v over secant square v dx over x. This time both sides times secant square v over tan v, it becomes secant square v over tan v dv equal to minus dx over x. If we take this term to the left hand side, it becomes secant square v over tan v dv plus dx over x. By integration of this two term, we get integration of secant square v over tan v dv plus integration dx over x equal to 0. We know that integration of derivative of function of x over function of x, it will be log of function of x plus c. So we know that tan v, its derivative is secant square v, so it becomes log of tan v. Regarding this term, we know that 1 over x dx, its integration is log x, so it becomes log tan v plus log x equal to log c. You can here put c or log c, both constants, it doesn't make any difference. According to logarithm rule, it becomes log x tan v, and in both sides we have log times e exponent, or this log cancel each other, so it becomes x tan v equal to c. Now if we just replace back v with y over x, we get x tan y over x equal to c. That is the required solution. That's all. I hope it can be helpful. Have a nice day.